Good evening to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kyarpuram, Bangalore. Today I am going to discuss about 13th session of Chemistry and 9th session of Gaseous State, which belongs to first semester BSc, affiliated to Bangalore North University. In this session, I have to discuss about application of Joule-Thomson effect to the liquefaction of air and hydrogen by Linde process. The main objectives of these sessions are the application of Joule-Thomson effect, then liquefaction of air and hydrogen by Linde process. The main After completion of this session, you will come to know what is the application of Joule-Thomson effect, then how to liquefy the air and hydrogen by Linde process. This will be known after this session. Then before discussing to this session, you already know about Joule-Thomson effect, inversion temperature, then freezing liquid mixture. You have already known in previous session or in PUC level. Now, the application of Joule-Thomson effect to the liquefaction of air and hydrogen by Linde process. Now here, for liquefaction of any gas, the following points to be kept in mind. The gas must be pure and dry. Here, some conditions are required to make that is the liquefaction. The first condition goes to the gas must be pure and dry. Second condition goes to the gas must be cooled below its critical temperature, because above the critical temperature the gas remains in gaseous state, but it cannot be liquefied above the critical temperature, but it should be cool in below critical temperature. That will give that is a liquid. Therefore, liquefaction takes place below its critical temperature. Third condition is the pressure applied to be sufficient large to cause the liquefaction. Even though critical temperature, we have to apply that is a pressure. It should be sufficiently large to cause the liquefaction. The pressure required to liquefy a gas is maximum at a critical temperature and decreases as the temperature is lowered. Linde used Joule-Thomson effect as a basis of the liquefaction of the gases. When a compressed gas is allowed expand into vacuum or a region of low pressure, when the compressed gas it having a high pressure is allowed to expand from higher pressure to the lower pressure, or from higher pressure to vacuum or to the region of lower pressure, it produces intense cooling. In compressed gas, the molecules are very close and the attraction between them are appreciable. As the gas expands, the molecules move apart. In doing so, the intermolecular attraction must be overcome. The energy for it is taken from the gas itself, which is thereby cooled. And this is the procedure how it is takes place. Now here this is the just container. Now fresh air should be a pass through this, and here it is just a compressor. It make that air should be a the molecules or gas molecules should be a compressed, and that should be a passes through this. It will becomes first compressed air, then it make that is a refrigerator, because it is a refrigerating liquid should be used to cool the sufficient proportional or sufficient that is temperature. Then it will comes along with this. This is a spiral, that is a spiral coil or spiral tube. It is called as a orifice, and here a small aperture, that is small hole will be there. From that the gas will be comes out. When it is a compressed air passed, no, the fresh air it should be a dry, and there are three conditions are there. No, here all conditions should be applied here, and the gas will be a pass through this. It is a it motor should be a compressor will be there. The molecules will be a bring to compressed are in contact to each other, are near to each other, and that compressed air will becomes, it should be a refrigerating liquid. It is cooled using a refrigerator liquid. Then it is a high pressure, it comes, and it is sudden comes out from higher pressure to lower pressure. The fall in temperature is takes place, and it will be a get that is a liquefy. That gas will be a because of cooling effect will be a takes place. We say that is a Joule-Thomson effect is nothing but simple. The gas is allowed to uh, from higher compression, higher pressure to lower pressure through a orifice. A cooling effect is takes place, or fall sudden fall is a fall that is in temperature, and hence the gas will be becomes a liquid. Like that it will becomes, and in orifice it's sudden cool, and the work is done, and it will be a converted into that is a liquid. And liquid can be, that is air liquid can be settle at the jar. This is the just it is a spiral. Okay, now here again that is converted gas, converted liquid gas, no, that is unconverted gas into liquid. That gas will be again comes, and it join to the fresh air, and again this is the recycling will be takes place. Therefore recycling continuously takes place till the till the all gases should be converted into liquid. This chamber is called that is a expansion chamber, in which the liquid should be that is stored, and this process is called that is a Linde process. Now here the apparatus, the Linde used an apparatus worked on the above principle for the liquefaction of the air shown in figure. I already explained. Pure dry air is compressed to about 200 atmospheric pressure. It is high pressure. It is passed through a pipe cooled by refrigerating liquid such as ammonia. Ammonia, that is a refrigerating liquid, is used as a ammonia. Here the heat of the compression is removed. The what it will be, that is it is a heat will be a compression, it is removed. The compressed air is then passed into a spiral pipe with a jet at a lower end. The free expansion of air at the jet result in a considerable drop of the temperature. Immediate considerable drop of the temperature. The cooled air which is now at about 1 atmosphere pressure and passed up the expansion chamber. If it further cools, the incoming air of the spiral tube and returns to the compressor. By repeating the process of compression and expansion, a temperature low enough to liquefy air is reached. The liquefied air collect at the bottom of the expansion chamber. This is the procedure to get that is a liquefaction of the gas. Now here this is, I have already explained everything here. Simple. At 200 atmospheric pressure it is passed, and here in this liquid ammonia will be used to as a that is a refrigerator, and it is cooled, it is compressed, and it is sudden that is a come out. Therefore here a fall in temperature will be takes place, and unconverted gas into liquid, that gas will be again joining to this fresh air, and it is a continuous circulating is takes place till the all gas is converted into liquid, and this process is called that is a Linde process. So far we have discussed I have discussed about the application of the Joule-Thomson effects to the liquefaction of air and hydrogen by Linde process in this session. Then might have already understood everything. Therefore I will ask some question, you have to answer them. First question goes to liquefaction of air and hydrogen is done in the First option Amagat process, second one is Andrew process, C1 that is a Linde's process, and D1 is none of these. I just give 10 seconds for you people. You have to answer it. The answer for this question is that is a C option, Linde's process. It is a Linde's process in which the liquefaction of the air and hydrogen is done in this process. Therefore, Linde's process is the right answer for this question. Then second question goes to liquefaction of air and hydrogen is based on the application of first one is Amagat effects, Andrews effect, Linde's effect, and D1 is Joule-Thomson effect. I will give just 10 seconds for you people. You have to answer it. Answer for this question is that is the D option, Joule-Thomson effect. Based on the Joule-Thomson effect, because the sudden cooling is takes place from higher pressure to lower pressure, the fall in temperature will be takes place, and that is called as a Joule-Thomson effect. And the liquefaction of the air and hydrogen is that is converted into liquid by using a application of Joule-Thomson effect. Therefore, D answer is the right answer for liquefaction of air and hydrogen is based on the application of Joule-Thomson effect. Third question, the Linde's process for liquefaction of air and hydrogen, pressure is used. A option about 500 atmosphere, B option about 200 atmosphere, C option about 250 atmosphere, and D option none of these. I will give just 10 seconds for you people. You have to answer the correct option. The B option is the right option for this question, because during the Linde's process, the high pressure will be used, that is around 200 atmospheric pressure. Therefore, the B option is the right answer for this question. Then this complete that is a session. For that preparation of this session, I have referred these books, and this complete the this session. Also, I have completed that is all sessions of gaseous state. Thank you.